We're looking at our last section now, dealing with multiple samples and data from experiments, and that's going to be with two categorical variables. Everything that we're going to be doing in StatKey is going to fall across in this row here. The two categorical variables are where we would get our graphs, so we'd be looking at bar graphs. That's what we did earlier. The things we'll be doing now is the confidence intervals and hypothesis tests both. So we'll be creating confidence intervals to say how different the proportions are, and we'll be doing hypothesis tests to say, are these proportions truly different? Is one of these truly larger than the other? And our p-value will be the determinant of that. So if we go ahead and open one of these up and just kind of look at what kind of data we're dealing with. If you go to edit data, you'll see that it lists it not as raw data, but as counts in sample sizes. So if you had two groups, let's say group 1 had 50 out of 100 people who thought something, you would enter it as 50 out of 100 like that. Let's say group 2 also had 100 people, but this group had 65. That would be how you would enter your data. And what the confidence interval is going to tell you is how different are these proportions. Now if you look up here in the original sample, you can see that they are 15% different. Group 1 minus group 2 is negative 15% or negative 0.15. That's the same thing as saying group 2 minus group 1 is positive 15%. So sometimes it's nice to phrase it in the positive. If you go ahead and generate this here, and you do the two-tail like normal, you get a 95% interval. And that will tell you not just what the estimated single proportion is, which you can get by just taking out a calculator and subtracting 0.5 and 0.65 to get 0.15, but it will make a confidence interval around that difference. In this case, you can see that the difference is somewhere between negative 28% and pretty much, if you round this off, 1%, negative 1% or negative 0%, meaning that they would be almost the same. So there could be a huge difference, or they could be nearly identical. If you went over to the hypothesis tests, the question you would be asking here is going to be dealing with, are they different? When you enter your data, it's going to be the same format. You can't copy paste your data, but thankfully it doesn't take very long to re-enter this. And you go ahead and generate for your hypothesis tests. One thing you'll notice, like all the other screens, all the other hypothesis test screens on StatKey, it gives you the null hypothesis right here. It is always that the two proportions are equal. And you'll notice that this is different here than the test of the means. I'll just open that up real quick so you can compare. For the hypothesis test difference in means, you'll notice that it uses the symbol mu, mu1 and mu2. Here it uses p, p1 and p2. That's because when you're dealing with proportions, we use the symbol p, or the Greek letter rho is what it usually is, to signify that we're dealing with a proportion. When you're writing your sentences, describing something like a confidence interval, you're going to not talk about the average anymore. You're going to talk about the proportion of people in group 1 versus the proportion of people in group 2. When you're doing your hypothesis test, you will want to choose your left or right tail based on which one is larger. You predict to be larger, P1 or P2. And let's say we expect it to be a right tail test. You would adjust this number down here to the original proportion difference. So hopefully your proportion is set up as group 1 minus group 2. That way it will match StatKey. So for example, in this case, you can see what happens when I do that. Most of my screen turns red. There's a good chance that this wasn't intended, this was an accident, and that I got my groups switched up, that really I entered my groups backwards or something, and thus I should have been doing a left tail test. Not always, sometimes that will happen, but that is something to be aware of. And let's say this was really what I intended. I would enter that in, and here I would get my p-value. Whenever we have a p-value less than 0.05, or whatever we determine our alpha value cutoff to be, that's where we're going to decide whether we reject or not. Rejecting means that we found a difference. We think that the two proportions are statistically significantly different, and that's what we're looking to find, is that somehow being in treatment group 1 versus treatment group 2 led to a difference between the groups. If it was an experiment, we would say that we know the cause of that difference, and if it was an observational study, we would just say we found a link. As you go forward, that's all the instruction I'm going to give you to get started. Both practice problems have instructional videos that walk you fully through the entire problem, so it may be helpful for the first one to walk through that and see the step-by-step process, especially when it comes to writing out sentences, things like that. For the second one, I'd recommend that you do it on your own without the video, and then use the video for additional assistance if you get stuck, along with asking questions in class. Good luck!